will just take sort of 5, 6, 7 minutes just to run over everything that's on the order. So I've moved round to where I was yesterday, just to make logistically it was easier that way for us. So let me change camera for you guys. And hopefully, there we go. Here's your second DL. So let's make a start. So the order itself, obviously with the 12-inch bonder, you've seen it. So we've validated it exists. So already on that machine, the standard accessories, which is the PVC tubing, the hose clips, the vacuum sockets, the mains cable, the equipment manual, all of that will go as standard. So I'm not going to waste time looking at that and showing you that. What I will show you, if I just, excuse me while I rotate the cameras, is I'll show you all of this stuff here. Okay. So if I try and just do wide angle, and I'll bring things to the camera as the easier way. So first thing is thin film bonding wax. So thin film bonding wax. Okay, so 1 tub of that. Glycol phthalate bonding wax. We've got glycol phthalate bonding wax. So that's the kind of clear, opaque, high temperature wax. We have quartz wax. So that's the kind of orange, kind of beeswax looking one. Okay, Ocon 200, the standard lower temperature one. We have bonding wax cleaning powder, which is obviously for debonding of the glycol phthalate. We have the non-solvent cleaning fluid, which is debonding. So the Eco Clear. Okay, so you got 1 bottle of that. We have 2 B270 glass substrates, 207 diameter. So these are wrapped in the white paper here. So we can see 207 times 2. We have 1 DL4, which is 1 DL4 machine. That's the first page. Second page is all the machine accessories. So with that, you'll get the air supplies, the water pipes, the vacuum pump connection assemblies, the power cable, the nitrogen assembly, the RV8 pump, which I've got connected to the rear side of the machine. Maybe camera might reach, might not reach. So hopefully you can see that RV8 pump on the floor. So that's your pump. Okay. Let me come back. Just get them a bit wider. Jig alignment pins. So the jig alignment pins are here. So these are the same as the last time. So these go in the head so that you can align the head centrally, so that the head, when it comes down, is central on the arm. So those are the jig alignment pins. You get the metric Allen key set and metric spanner set that we give with all of the systems, which I don't think is here, but those are, we've got so many stock of those, so I'm not worried about them in the slightest. In fact, they're inside one of these bags. So that's all the jet lube. No, that's okay. I'll get them, no problem. Not worried at all about that. Electrical wise, you get electrical enclosure key. So this is the little black key I'm going to use. So I've got 2 sitting here because I had one in my pocket. Always handy to have. We're going to have lapping plate lifting eye. So those lifting eyes are so that you can, here's one here actually. You'll get the lifting eye so that you can put that on the plate and lift it off with some sort of lifting equipment. So that's fine. You'll get, let me see, a jig alignment spacer, retaining pin, plate change frame guard. and the instruction manual. So those are things we'll pack with it. I don't have them here. Jig-wise, we've got 4. So I'll move up slightly. So we can see the 4 jigs on the trolley. Okay, I'll bring the trolley closer. Okay, so here's our 4 jigs. So there's a little bit of finishing work to be done to the critical faces on these, which is why we need a few days next week. Some of them are finished, some of them are in progress. With those, we'll get the jet lube syringe. So inside this bag here is all of the accessories. So your jet lube syringe, in fact, the metric Allen keys and stuff are in here as well. So there's the Allen keys, etc. So they're in this bag. So that's fine. Okay, so that accessory bag's got all of the jig accessories in it, with the manuals and stuff. So that's fine. The jig load gauge to suit PP9. This is the jig load gauge here in the polythene. So this is where you measure the load on the sample. And we've got a standard loading weight of 9.75 kilograms. That's what this box is the weight itself. Then on page 3, we have plain loaded cast iron test block. So I'm going to use the lab one for the demo, and this is your one here, packed. Okay, so this one's finished in the polythene. The calcined 9 micron, so the 2 containers at the back here. So we've got 15 micron on the top, and there's 9 micron underneath. And with those, we give you the cylinder and the beaker to then be able to decant that into your cylinders. Okay. The glass lapping plate, so the glass version of the 700mm I don't have here, but I know it's finished because I've seen it already in the workshop. The 15 micron we've covered. The cast iron lapping plate, 700. I've got the lab test plate on the machine because your machine is finished. Your plate is finished. So this plate that's inside the machine is actually the lab one. So we'll take that out next week and we'll put your plate on the machine. The Granite Master flat. So this is your 0 reference. So this here is your Granite Master flat. So this is 0 so that you can measure. You get a little protective cover for it just to try and stop people scratching or any particulates getting on it. You have 2 double peri-pump systems, so 2 pair ones. So we've got one on the right-hand side here, so that's 1 pair 2, and you've got one on the far side there through the glass. Okay, so the labelling's still to be finished on those. So again, just some minor jobs still to complete next week. Some simple jobs. Then we have, obviously with those you'll get the cylinders, the pickup tube, the slurry tubing itself. You'll get some screwdrivers, which you need to set those up. There's actually your USB sticks with the manuals. And we've got the pack testing certificate, the electrical testing certificate. So that's all done. Okay. And the beaker and the funnels are included with that. We've got the single dial gauge, so that's where you're going to measure. So use it this way. So you'll 0 that on the master flat, and then you can check your test block or your plate shape. And then we've got 2 cylinders themselves. So those 2 cylinders have a little bit of assembly to finish. I'm going to use cylinders from the lab today just to do the demonstration. And on the final page, we have the glass test block, which is here. So this one is the glass test block for the glass lapping plate. And then you've got your 3 substrate holders. So this is what I was talking about earlier. So if I tell a lie, the cylinders are here. So that's your peri-pump cylinders inside the boxes. So those are all finished. I didn't think they were finished. I've obviously managed to get them done. Okay, so this is your retaining rings for the bonder. So if I try and show you, this is the large one for your 8-inch. And then if you're going to do the slightly smaller one, this one will fit inside this one. So it becomes a double retaining ring for the smaller size, which I think is to do your 6-inch wafer. So this is 163 opening to do a 150 wafer. And then what you've got is, you've got one similar to the one we had in the lab to do the 4-inch, so to accommodate the 112 millimeter substrate. So normally you've got, yeah, this is for the bonder. So these are the rings that we spoke about just before we ended the call that Nikolai was asking about. So these are the retaining rings for the bonder. Okay. So those are also on the order. And the special chuck face assembly, so those are here also. Again, they have a little bit of work, a couple of days worth of work. So again, they're the same as the ones we showed you the last time. So these are the ones with all the vacuum channels to be locked off. Yeah, to do the different sizes. The ones that are on the jigs, I can maybe pick up one of the jigs to show you. So I think it's this one is finished. So you can see the same as the last time. Okay, just a very, very heavy. Okay. So the ones that are on the jigs are those 3 separate chuck faces, and then the separate special chuck face assembly for all of the standard diameters that you can lock off the vacuum channels. 2 are on the bottom of the trolley. 2 are here on the top of the trolley. Okay. So those have a little bit of just flatness, accuracy to be tuned on them. Okay, so they're nearly finished, just a few days work left on those. Okay, so that's everything that's on the order. The only thing that I've not shown you are the 2 plates themselves, because they're very, very large. So I've left them in the workshop. Okay, but yeah, it's heavy. So we have a pneumatic lifter. So we kind of do a kind of shackle, and where we put the eye bolt, so in the center. So we put the eye bolts on the center of the plate, and then we've got the shackles to put over it onto a heavy lifter. And then what we actually do is we can bring the lifter through between these two to raise it up, to lift it out, and then we can bring all the way out the machine. So it's the same as the first machine. But we'll have the plate, the cast. I think the cast iron one is probably the one that the machine will ship with, unless you have some desire to have the glass one inside this machine. So that's maybe something you can let us know, which plate you want shipped with the inside the system and which one you want packed separately. Because I think there is one glass and one cast iron. Yeah, that's fine. Yeah, yes, you need to be more careful with that one, absolutely. So we'll pack the glass one separately, and we'll put the cast iron. That's the standard way we would do it, but I'm happy to ask the question if there's a preference otherwise. Okay, we'll go with that unless you tell us otherwise in the next sort of couple of days. Okay. Okay. So yeah, so the jigs, you mean the process jigs, the PP9s? Or are you talking about the heavy lifter to lift the plate on or off? Yeah, so those, my understanding, I could be wrong, I'm assuming, not knowing the full detail, is the chuck faces that are on these jigs are the same as on the other system that we did a few weeks ago. Yes. Yes. Yes, absolutely. Yep. Yep. Yeah. So on the chuck face is the 3 for the 100mm, and then I think this one, if I bring it closer to the screen, is the same as the one that we have. Let me turn it so you can see a bit better. So then you've got the individual vacuum holes to lock off depending on the size that you want to process. Yeah, it's this one of the small Allen keys that come with the Allen key set. Yeah. Yeah, let me just, yeah, I'll just check. I've got a steel rule here. So the smallest size that's open, yeah, so 25 read. The first vacuum hole is around 27, 28. So anything less than that will be chucked if you've locked all of the holes off. So the first vacuum hole is actually around 7mm, which is permanently open. The second one's around 16, which is permanently open. The first one that you can close is around 27, 28. Yeah. Yep. Just doing that now. So. Yeah, if you want to capture that. Yeah, I can give you that. I can send you that image as well. Yeah, let me take that picture right this minute, and I'll just lay my steel rule on it. Try and get it roughly, and I'll grab my camera. Just the lighting's terrible. Oh, there we go. Let me just, hopefully I can even just send this to you this minute. Your email is shop, isn't it? So shop at SLK. No. Oh, yeah. Now, let me just quickly grab it off my email. My phone doesn't have it pre-programmed. EQUM dot RU. I'll just call it Chuck. Hopefully it was sent. So hopefully you receive in seconds. Yeah. If my steel rule's 1mm so off, I apologise. Just to give you a guide. Yeah, you can analyse it a bit better. Okay, so from where we are, let's try and move forward. So that's everything that's on the list. As far as my understanding and the paperwork shows me. So hopefully that covers everything. So as I say, apart from the 2 plates. Okay, so let me change my camera a little bit. Right. And also get a look at the test document. Okay. Right, I'm on the right camera now. Right. Yeah, absolutely. I'm just getting my documents ready. Give me 1 second. Yeah, so my camera only goes so far, so bear with me as I try and shuffle my camera a little to accommodate. So you want to have a look at facilities panel. So just give me 1 wee second. Hopefully I can stretch. Yeah, should be okay. I just can't see what I'm showing you because I'm round the far side, but we'll try. So I'll try my best to okay, so this is the main facilities panel. So we've got the drain, we've got the fan. Okay, the machine's powered off at the moment, so the fan's not turning. We've got the vacuum, which is connected to your vacuum pump. Okay. And then we've got air inlet, nitrogen inlet, and at the bottom we've got water. So just because of where I'm doing it within the lab, we've kind of had to make up a separate sub-water fitting just so that I can get it connected to our supply, which is not non-standard outside. Okay. Okay, so that's that. Okay, and then what we've got on the power side, I can show you 415 volt. It's rated at 32 amp, which is on the side here for the socket itself. The machine is a 25 amp, so you can see here's the serial plate, which Mark will send you that picture after today's call. Okay, so DL43 serial number 860-04-21, 415 volt. The mains power isolator is on at the moment, the earth's on, and you've got the CBO. Okay, so any other questions on facilities? The tank is not included as far as I know, because we don't know what you're connecting to. This is, to be honest, this tank here is just an empty SF1 container. As far as I'm concerned, for today's purpose, that's really the same containers we use for the SF1. But it gives you the option that the pipe work is the drain pipe works the same on the DL as it is the DP. It's the braided reinforced hose. Okay. 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 Let me go back with my camera because it's right on the end of my limit of reach. Okay. So the other thing I might do before we power up the machine is I'll just show you inside the electrical enclosure. So hopefully I can come this way, and I'll just use the key that I used before just to show you electrical enclosure. Okay, so similar to the DP in terms of arrangement. So hopefully from top to bottom. Okay, everything finished. Okay, just close it again. So again, it's got warning labels to say that you really need to disconnect the power before going into those sections. Okay. Okay, that's that. So let's have a look at, let me go through the FAT test document. So customer is stock, order numbers 221023. This is part 3 of the order. So I'm just typing as we're speaking. So inspected by myself. So it's a DL43. It's a 415 volt. It has 4 heads and it has 8 pumps. So I'll just show you the 8 pumps. So we've got, on this side, we've got 4 pumps. So we've got 2 in the upper and 2 in the lower, which is a 1, 2, it's a 2 per 1. And then we've got the opposite. Well, the camera won't stretch around the corner, but you can see here. Then we've got the pumps. So there's a pair of pumps here and there's a pair of pumps here. Okay. I've just not connected the tubing to them quite yet, just with the timing that I've had this morning. So I can get that after we finish. Yeah. So we need the facility. Yeah, you go through a lot of slurry, obviously, just with the plate size, and you want to be able to deliver slurry, fresh slurry to every jig, ultimately. So what we've got is the same as the last time. So on the left-hand side, the labelling still needs to be done. I need to point that out. So we'll finish that on Monday. So on the left-hand side, that will service stations 1 and stations 2. So we've got 1.1 will go to station 1 from the bottom, and 2.1 will go to station 1. And then we've got on the top side, then 2.1 and 2.2 will go to station 2. So the left-hand side services workstation 1 and 2, which is the front side. And then the right-hand side pumps will service stations 3 and 4 at the rear. So level 1 and level 2. So that's 1.3 and 2.3 for station 3, and 1.4 and 2.4 will service station 4. So what we have is the same arrangement. So what we've got, if I have a look inside, so what we'll have here is the plate's going to go counterclockwise, so this direction. So the fresh slurry feed for station 1 will come from these 2 tubes, which are going to be 1.1 and 2.1. The fresh slurry for station 2, so head number 2, are going to be fed to the exterior, so the exit of jig number 1 to feed station 2. So the slurry will drop here and go that direction. So this is 2.1 and 2.2. So all of these 4 tubes attached to head 1, 2 of them servicing head 1, and the 2 exit service head 2. These are all coming from the left-hand side. They're coming from this side. Then we've got the exact opposite on the right-hand side. So from the touchscreen, the right-hand side, so here, this right-hand side abrasive unit, this will be pumps 1.3 and 2.3, which are going to be fed here. And then we've got 1.4 and 2.4, which are going to feed station 4. So I'll do the check of one of the flow rates, the same as I did the last time. I don't want to waste time doing all of them, but they'll all be verified internally, but for this purpose we'll just do the one. Okay, so we've got the 8 pumps. The special instruction number is the same as the last time, I believe. So that number for my reference is 2460. 2460. The serial number we've already quoted, which is 8600421. The monitor serial number is number 1, 00001, 415, 50 to 60 hertz, 3-phase plus earth, 25 amps. The Windows license key I need to get, there's a label that needs to go on the monitor. So I'll need to get that. So I'll do that before it ships to get that number and make sure the label's in place. The software revision I'll get when we power up the machine, which will be the same as the last machine, which was 20028, but I'll show you that on screen. And that would conclude the first page of the FAT test. So let me go through the other items. So we've already said the DL4 is a 25 amp, but the mains cable is rated to 32, so I've already shown you that. Ensure the slurry and water pipes are secured and don't foul any moving components, and check for leaks. Okay, so what I'll need to do is I'll need to power that one up. Okay, so I'll power up the machine up and we'll check that the water pipes and the slurry pipes are all secured. And when things move, they don't get filled by anything, that there's enough slack. So let me power up the machine. So again, just the same as before, press the power on button, and then we'll see the screen. The light will illuminate at the bottom left-hand side, the same as the bonder. It'll go orange initially, then go green, and it'll start to go through all its startup checks. Just get the camera. So I'll show you the software version just so we can include that first page. Okay, so what we've got is which delivery modules. Because there's options, then we need to decide which ones they are. So they're one pair 2-1s. So those are the ones that are on the system. So we can accept that. So let me I'm just sending you these serial plates, Nikolai, while I remember. Mark will send these officially anyway. You'll get the same images from Mark later, but just because I've just sent you these other things, it's shop@equm.ru. So those are coming now. So we've set those up for one pair 2-1s on the left and on the right. So we can say OK. We'll go through all of the system checks like we did last time. So obviously if we've not got air, etc. So the front two doors are open, so it reminds me. So that's a good thing. So I'll close those and it finishes the system checks. And then it's going to do just a check on the sweep, get to the home position. So each of the heads in turn. So that's now finished, head 1, 2, 3 and 4. The Bluetooth is always the last one that does need a little bit more time just to conclude. Obviously, we've not got any gauges connected at the moment, I don't think. I'll need to check. But it goes through its own diagnostics just to make sure the Bluetooth is active. So that just usually needs about 30 seconds or so. So I'm just going to press the stand clear just to show all the buttons. There we go. Bluetooth's now finished. And now all the full system's ready. So we're good. Before I can continue, then I go to the main screen. Okay, same as the last time. Going to go into the options screen and the software versions in this bottom left-hand corner. So again, it's the same version as the last time, 20028. It reads, it's a little bit not great on screen, but 20028. So the exact same software version as the other machine. Okay. Again, we can lock out with a password if you want the user to have restricted items. Generally speaking, it's not used so much. We can save and exit those things. We can connect it to a network if you want to by Ethernet. We can go into the files. Again, the same as the bonder. We can look at the hard drive. We've got the journals folder where all the error logs are. We've got the settings file and any recipes that you wanted to save. Those would be saved there. Of course, if you stick a USB in, you can store to external USBs as well. And you can navigate to that if there is one connected. Okay. We've got the pair gauges. So that takes us into the Bluetooth section. So we'll do that when we get into that section of the FAT test. Okay, so I'll just close that for now. We can load the jigs. So what we can do is we can take the pressure off the piston and basically load or unload where required if we want to do that. Okay. And we can update the software. So the same as the last time, there's a password required to be able to update software. It is the serial number of the machine. So 860-04-21. And then it will allow you to load whichever file we ask you to do as a batch file. It will load that file, the machine will power off automatically, and then you just need to power the machine back up and check the software revision in the bottom left-hand corner, and that's it taken. So we'll save and exit. Okay, so that would conclude the first page of the FAT test, with the exception of the Windows license number, which I'll get put on the sheet before I send to you. So just this item here. So for my purpose at the moment, I'll do that to remind me to go back and complete that before I send it to you. It's just the sticker's not on the panel, but I'll get that put on. Okay. So I need to check all slurry and water pipes are secured. So when it's went to the home position, actually, that's kind of done that check for me. So now I've gone to the machine. I think there's a door that says it's open. So I just need to check the doors are just latching correctly. Yeah, so that's just clear. One of the doors at the back just wasn't quite closed. So it said basically the doors were open up the top here, but manual mode and it's ready. So again, we've got the same screen as we had the last time. So we've got plate rotation, which is fixed direction, is counterclockwise. We've got carrier rotation, and we can change the direction from counterclockwise to clockwise. We can change that, and the little arrow changes direction, just to tell you if it's clockwise or counterclockwise. The plate rotation speed is 5 to 100 is the range, so max is 100, same as last time. And the carrier rotation is 5 to 60, which is the same as the last time. The static position is then the position of either the test block or the jig on the track. So if you're wanting to maintain a certain shape of plate, if it's convex, then you're going to be overhanging on the outer edge. If it's concave, you're going to be overhanging over the centre recess. So that allows you to manage that. If you want to maintain a certain position, then usually 50% should be sufficient. Usually when you're conditioning, then you're going to then use the 1% or the 100% to shape it in a particular direction. So I'll show you that shortly. We've got the availability to put all the heads up or all the heads down, or individually. We can put them up and down. Okay? Or all down, all up. Okay, question, Nikolai? No? Okay. And then what we've got is all of the flow rates. Okay? So we've got... For the flow rate. No, the flow rate is 100 per pump. Yeah. So basically, 1.1 is max 100, 1.2 is max 100, 1.3 is max 100, 1.4 is max 100. Okay. So total you could have 800 millilitres per minute going onto the plate if you had all pumps running maximum. If it was the same fluid that was in all of the cylinders for all of the pumps. But you can up to 100 ml per minute, same as the last machine. But for each individual jig, it will be 200 per cylinder. Because what we've got is, for head number 1, we've got, let me just check, so really this is head number 1's pumps. So 1.1 on the lower ABS unit and 2.1 on the upper. So 1.1 is on the lower ABS and 2.1 is the upper ABS. Okay. The cylinder total is, no, it's less than that, much less than 15. I think it's 4. It's either 4 or 4.5. I'll double check. I think it's 4 or 4.5 litres per cylinder. So it's kind of double what the PM6 does. So I think it's 4 or 4.5. Yeah, so it's 2 litres per cylinder, so 4 litres in total on the machine. Yeah, for PM6. Sorry, for PM6 and LP70. The cylinder is a 2-litre cylinder, but you have two of them. But the cylinders that are on the DL, I think it's 4 or 4.5, and you have two of them servicing each head. Okay. So what 100 for the plate and 60 for the carrier or the jig. Okay. Yeah, so the way the panel's laid out here, if you think about it, the left-hand side here, so 1.1 and 2.1 is all for head 1. 1.2 and 2.2 is for head number 2. So this is all the left-hand side abrasive systems. 1.3 and 2.3 are to service head number 3, and 1.4 and 2.4 are servicing head number 4. And so this half here is on the right-hand side if you're using the touch panel as the reference. Yeah. So basically this half of the slurry systems is coming from the left-hand side, and this part of the slurry system is coming from the right-hand side. Yeah. So the right-hand side is servicing the rear two heads, and the left-hand side is servicing the front two heads with the touch screen as the reference point. Okay. Okay. So then we've got, if you wanted to flush, so if you connected up an inlet of water through the pumps, then you can do that. You can agitate the left-hand side, level 1, or left-hand side, level 2. So if I do it with the right-hand side, because that's the one I was going to use, if I do the right-hand side, this is the right one, then what happens is this abrasive unit here, roller, is now rotating. I've not got a cylinder on it, but you can see here it's rotating. Yeah, and then I can show you this is the agitate R2, which is now agitating level 2, which is the top side. So that's the difference between agitate R1 is the bottom side, so the bottom side of the right hand agitation, and R2 is the top side. So I'm going to use R2 today just for the demonstration. It saves me having 4 cylinders and lots of liquid, just keeps it less messy. So this is the one I'm going to use here, level 2 on the right hand side, which is servicing, it's either head 3 or head 4. I need to check which one it is I'm going to use. Okay. And then at the bottom side on the screen, again, same as the last time, is more to do with the Bluetooth. So we can program a removal target. We can 0 at the start of the process, and then we can set a target of 100 microns, 200 microns, 300 microns, and then activate it with the button. Yeah. So we can decide, why is that button not? Yeah. So we can activate station 1 would stop, station 2, station 3, station 4. Okay. So 1, 2, 3, and 4. So we can do that later in the fact test.
Robin, if we reach the target, jig, stop separately or all in the same time?
Yeah, you can program them. So, for example, you could have all of them removing, say, 100 microns, but one might get there just marginally faster than the other, or the targets could be different. So jig 1, 100, jig 2, 200, jig 3, 300, jig 4, 400. Then when they reach the target, the jig will just lift up, and it will have to wait until the other ones finish.
Okay.
The other jig will continue. Yeah, the other jig will continue until the final jig, or you decide to stop the process. It would just keep continuing until the 4th jig is finished if you're using the targets on all 4 jigs, if you've got 4 jigs processing.
Okay, and the next question, can we set the speed of rotation each jigs different, or it's only one speed for all jigs?
The carrier rotation is just one setting for all four. Okay. It's not individual speeds for individual heads. It's one carrier rotation speed universally on the machine. So this is this setting here.
Okay.
Yeah, just one. Yeah. What we found is you may well have, I guess what you're saying is if you had one at 100, one at 200, one at 300 and one at 400 removal, you might want the carrier rotation on jig 1 to be slower than the carrier rotation on jig 4 so that they all try and finish around the same time. But yeah, that's not, from a design point of view, we didn't think that was useful, especially having jigs rotating at very different speeds on the same plate. If you've got one that then causes some damage because you've been too aggressive with the speed, then you're going to damage all four samples. So it's to try and avoid that kind of disparity. So I get your question, but the design at the moment is one carrier rotation fixed for all units, not independent.
Okay, Aaron, thank you.
Okay. So that's the kind of explanation of that screen. So let me go back to the test itself. So we want to move everything. The emergency stop switch is on the control panel and it's got a yellow decal, which it has there, yellow decal background. So that's fine. Switch on the air, electricity, water, air, vacuum, slurry. Release the e-stop, switch the machine on, control panel lights up, we've done all that. Press OK, all the green lights come on, press continue and choose the function you want to use, which at the moment is manual mode, we've done that. Check the operation of the emergency stop switch and ensure that when the switch is pressed, the machine returns to a safe state. In other words, the jigs lift and then everything goes back to the home or the park position. So what I'll do at the moment is I'm going to bring on some water. So I'm going to just spray some water just to lubricate the plate. So I think my water supply is currently off for some reason. So let me just check. I think the mains is off, so give me a second. Excuse me, I need to go around the long way. Give me 1 minute. Excuse me a second while I try and I've got a little water supply problem. I'll be 1 minute. Okay, got water now. Apology. Aye, isn't it? Okay, just wetting the plate a little before I start. Apologies for that. Let's check this gun. Yep. Okay. So what I'm going to do first of all is just start the machine and then just press the emergency stop just to make sure everything starts and stops. So let me just do very slow rotation, very slow carrier rotation. What I'm going to do, what I've set up is the same as the last time. So the last time I've got nothing on head one. I've put one of our process lab jigs on station 2. It's not one of yours. Nothing on station 3. And I've put the test block, which is the lab test block, on station 4. Just easier to test and do some of the functional tests with the loading, the test block, rather than potentially damage the drive ring on the chuck face for the jig itself. So I'm going to use station 4 at the back side. So normally I've always put the test block on station 4. What you will see with station 4, and I think we had a little bit of discussion on this one the last time, you can see with what's on the standard station that the jig locks into the head on this central black section. It hooks in. You can see just from the distance, rotate it slightly, the block in the centre is a solid block. It's not got an open aperture like the other ones. I'll bring this higher actually, so you can see it a bit better. So you can see this has got the open aperture to take the jig, so it's got the little housing here. Whereas on the test block, you've just got a downward loading push. So just a solid block. So if you want to change this from station 4 from being a loading test block station to a jig process station, you just replace this solid block with one of these blocks. So you'll get that spare with the system. So we discussed that the last time. So I think that's sitting, I think it's actually sitting in the workshop. So we'll probably leave, the first thing you'll have to do is condition your plate, obviously just to get used to the running. So we'll leave the loading, the test block on the machine. But if you want to change that back to being a 4th workstation, then you just exchange it for this block. And it's just to rotate this one. So there's just basically the 2 little cap screws in the back side here. In order to put it on, you can just match it with those ones. Okay. So the jig and the test block and the plate are all from our lab as standard. Okay. So I'm just going to close the doors. And then we can watch the process. So we'll have the plate. So make sure I get all these settings correct. So we're going to have the plate on at slow speed. We're going to have the carrier rotation. And we're going to make it go the same direction as the plate, counterclockwise for the moment. I'll keep the static position at mid-track, so nicely overhanging the outside and the inside recess. I'll use station 4, okay? And I'm going to use the slurry from, I think it's either, I need to check if it's 2.4 or 2.3. So I'd taken that out to do the flow rate checks. So I'll just need to put it back in temporarily. Give me one little second just to run the tubing round. Okay. So just putting the tubing back in because I'd taken it out to do flow rate checks before. So again, I'll just put it at a kind of medium flow rate. I think it's this. It's one of these 2. I've now forgotten which one I did. And we'll agitate the upper right, which is the one at the top side here. Okay, and if I press start, we get the plate rotating. Okay. I've got water dripping from pump 2.4. Just the camera angle won't see it. Now we'll see station 4 come down gently. Okay. There's a little bit of corrosion on the plate, so there might be a little bit of irregular movement, shuddering, just as it starts to. And I'm using water rather than abrasive powder just to try and keep the machine clean as possible. So there'll be a little bit of frictional forces that are more than normal. So if I go and press the emergency stop, which I'll press now, then the head basically lifts up. So the emergency stop's still active and the head has retracted to try and protect the sample. I'll reset the emergency stop and then we'll see the head of station 4 go to the park position or the home position. So you can see that moving to the outer position now, which is its home position. Okay. And that's it, finished. Now the machine's back active again. So I'll do that one more time, just so you can see what happens on the touch screen. I'll switch between the two. So again, start the process. Okay. Plate's rotating. The jig's now rotating, and then it'll start to lower to the plate. Okay. And then I'll show you when I press the emergency stop what happens on screen. So now the head's down. I'm going to press the emergency stop. It says manual mode, upper doors are open, which is the same as the emergency stop. The head is then lifted back to the upper position. And then when I reset the emergency stop, station number 4 will go to its home or park position. And then once it's at the home position, then that error clears on the screen and allows you to then interact with the machine again. Okay. And in doing that, also, it's made sure that the slurry tubes are not being tangled by anything, which was the other check. So that's check 6. Check the operation of the emergency stop switch and ensure when the switch is pressed, the machine returns to a safe mode. And then when you reset the EMO, the jig lifts before returning back to the home position. So we can confirm that. Check that the fan is powered up and is blowing in the correct direction. So the easiest way for me, and again, it's way around the other side of the machine. So I normally just take a sheet of paper and I just hold it against the fan. And it's holding the piece of paper. So I'm happy that it's trying to pull fresh air from outside into the machine to try and keep it cool. So that's fine. Next check is ensure that the PC and touchscreen clock times are changed to your time zone. So the clock currently says 7 minutes past 3. So which is the current time, because I'm at 7 minutes past 1. So that's the Russian time zone. So I can check that. So go into manual mode now, check that plate flush works, that the switches are on and off, the slurry runs to the main plate, the DI water guns work, the nitrogen gun works, and the drain doesn't leak. So let me go around those one by one. So let me do the switches for on and off. The slurry runs to the main plate. So let me just turn the carrier rotation off, the plate rotation off, and only the pump. So let me get my camera angle good enough that you can see, hopefully. So can you see the slurry tube and the water coming out? Or maybe this side's better. Is that better? Yeah. Okay. there's only the button which we have, but what you would have to do is connect an external water container to the slurry pumps to then flush the tube. So it's more a tubing flush rather than a machine flush. So what you would use is this flush level 1 and flush level 2. So if I stop that at the moment. So what if you do flush level 1, what it's going to do is run all the pumps from level 2. So what we've got at the moment, so now I've activated it, you can see the pumps both on level 2 are running full speed. Yeah, so you just need a water container and just put a pickup tube into some water bottle. And then you basically just press the button and it just flushes the tube. So it's more like an end of day tubing flush. Okay. Yeah, so that's what these two buttons are. Okay. So in the agitate is obviously agitate, left-hand side lower, left-hand side upper, right-hand side lower, and right-hand side upper. So for today, we're going to use the right-hand side upper. Okay. Right, next. Gun. So we need the air gun and water gun. So let me just open the doors. Oh. Give me 1 second. Okay, so this is the water gun for left-hand side. Sorry. Someone was asking me a question there. Nitrogen gun. Okay, so that's the front side. I'll go and do the back side, but I'll try and point the camera so that you see it. So nitrogen backside. Okay, and water backside. Okay, nice and easy. So that's okay. And now looking at the vacuum. There's the next item. So I think the vacuums are actually on. Oh, I do have one leak by the looks of it. So maybe just a little tube. So station 1, I can hear it. So I know there's a leak. So there's a tube that's popped. Station 2, if I turn 1 off, station 2 is really good. So station 2 is sitting around 29. Station 1 has a slight leak. My camera won't stretch to the other 2, but I'll read them. I'll put them on individually. So 3 also has a leak. 4 doesn't have a leak. 4 is 28. So I need to have a look to see. There must just be, just with us running it, caused a little leak. So I'll take a note of that. I'll get someone to check that for me as I do other things. So head 1 and head 3, I have a little bit of an external. Yeah, there's a little hiss. So let me take a note of 2. Station 2 and station 4 are okay. So, right, so station 1, station 3, I'll get a little note of that. Give me a second. And station 3. So we'll get that fixed before we finish. And I'll come back to that. Okay. Now we're looking at speeds. So we're looking at using the tachometer to check the speeds of the heads and the carriers. So what I'll do is I'll check the plate speed at both settings, and I'll check at least one of the heads, if maybe do two for the other parts. So let me just dry off. I might need to dry the edge of the plate because I know that another thing I need to do, I need to override because of this check. I need to be inside the machine. So I have to be careful, obviously, from an interlock point of view. So from a maintenance perspective. So let me just dry off the plate a little bit. So the plate speed I'll put up to 20. And just try and throw off the water a little bit. Okay, hopefully that's enough. So the checks are at 10 and 100. So let's do 100 first. That'll throw off more of the water. So I've got 101. Just do one more time. Yeah, 101. Okay. And I'll just check it. 10. One more rotation. 10.3. Okay, just check it one more time. One more rotation. 10.3. Okay, so I'm happy with the plate. So let me just record those numbers. It's okay. Next item is to move the cursor to change the carrier speed and increase and decrease the carrier speed just to prove that the changes are active. So I'll just wet the plate a little more. Just because I'll need to bring something down onto it. Okay. So I'll just keep the plate speed slow at 5. I'll make the carrier speed at 5 also. I'll put carrier 4 down. It's the easiest to test. So carrier 4 is rotating. Now it's going down. So it's turning at 5 RPM at the moment. And I'll change it to 50 once it's down. Now it's speeding up for 50. Yep. And I'll change it back to 5. Yep. So basically we managed to increase and decrease the speed. The actual test values that we need to do are at 10 and 60. So I'll do that for station 4 where we're here. So I'll do 10 So I just need to check. Oh, there's no tackle tape. Right, I need to stop. I've taken the tape off. So I just need to put a little bit of the tachometer tape onto that head so I can measure it. So give me 1 second. So just so I can get it high up the shaft. That should do it. So I said 10 and 60. So I'm at 10 just now. So there we go. One more rotation. 9.7. Sorry, just someone discussing the vacuum. Apologies. Right. Then I need to go to 60. So 9.7. And this is 60. Check. It's 59.5. So I'll just stop that. It's noisy because of the water. So 9.7. 9.7 and 59.5. And then I'll change the direction of head 4. And we'll do 60. Oh, sorry, I've just tripped it. I just hit the door with my elbow. Apologies. Tap, that'll do. Tap. 59.4. All right. And I'll just drop it down to 10. $9.8. So let me just record those. 9.8 and 59.4. So pretty balanced across both sides. I wasn't going to check the other ones in terms of head 1, 2, and 3. The same principle applies, that we would check these anyway internally. So these have already been done. So even if I read out, you'll see that from the check sheet when we send you the internal checks. So the internal checks for head 1, 2, and 3 at 10, it's 9.6, 9.5, 9.8, and at 60, 59.8, 60, 59.7. So very, very similar numbers. Okay, so I wasn't going to check all heads at all levels, the same as we did the last time. Just we picked one head. Okay, if that's all right. Reasonable. Okay, the next item, number 16, is ensure the carrier travels 60 millimeters over the edge when it's in the park position. So we've got the... Okay. So when we run it, it obviously moves from 1% to 100%, which is a slight overhang and slight underhang. So it's equidistant with 50%. But the park position, we set the limit switch so that it parks it at 60 millimeters roughly from the edge. So again, what I'll do is I'll run the machine and then we'll emergency stop it, and then we can run it to the park position when in fact I'll be in the park position just now actually when I think about it. So let me just measure station 4. So station 4 is sitting between 60 to 61. So I'm quite happy with that. And they've all been set the same. So 16, 17, adjust the sweep position and ensure the carrier sweep length changes on all carriers. So what we just want to make sure is that when we change the sweep position, they're all linked together anyway. So if I change the carrier position, then we can do that. Sorry, just discussing with Mark there is actually, there was a bit of tubing on station 3 that was causing the vacuum issue. Station 1 still seems to have a slightly different issue, so I'll just turning head 3 on now, and I've got 28. Just check station 4 again, and again 28. So I'm happy with those two. So station 1 is the only one that still has a not so obvious leak. So let me just amend my sheet. So station 3 is okay at 28. Station 1, I'll get someone to come and have a look on my behalf and we can stop what we're doing. So adjust the sweep position to ensure the carrier sweep changes on all carriers. So I'll leave the camera where it is, and what we'll do is we'll run the machine. So I think there must be a door open. There is that one there. Okay. So I'll set the sweep position at 1%, which means it's going to be on the outermost part. And I'll use head 4. Right, I'll use head 2 as well. Okay. So what you'll see is once both of them are down. Okay. So both of them are down. If what you want to look at is the outer arm position, so I'll move that to 100. And it's a very slow, steady movement. There's not enough friction. There's too much drag. There's not enough fluid on the plate. Yeah. Yeah, there's not enough weight on the plate. And it's really sticking the jig as well. So this is the most difficult part of trying to do just with water. You really need some abrasive. This one's just jammed up slightly. There we go. Okay. Yeah. Yeah, there's too much friction, not enough particle. So you can see now the overhang is very, very little. There we go. So now the arm's moved in quite a lot. Oh Jesus. Yeah, because there's no abrasive. Yeah, there's no abrasive in it. It's part of the problem. Yeah, I know. It's so much easier with abrasive. But certainly the arm is moved. That's the key. So when you change the position on the screen, the heads that are down all move. Okay, check the download speed of all available carrier heads. So this is the key for you guys when you've got a sample. So if I just position the camera. So what we want to make sure is the jig doesn't come down quickly. Yeah. Yeah. So let me use station 4. And what we want to notice is with the weight of the jig that the cylinder the jig just drops nice and steadily towards the plate. So if you just watch the speed that the jig travels towards the plate. Come back a little bit. So, oh, sorry, that's station 4, not station 2. So station 2, now it'll start to go down. Cylinder's released, and now it's gentle. Okay, it's not a quick, jerky movement. Okay. Again, no particles. So this is why it's metal on metal at the moment. So we'll put some carrier fluid, so kind of oil-based carrier fluid in, with the water just to try and give it some buoyancy. Okay. Check the peri pumps are fitted the correct way. Well, we've already checked that with what we've shown you so far. And then now the flow rate check. So what I'll do is I'll do the flow rate on station, I think it's 2.4, which was the pump that I've been using there. So one of my colleagues is just putting some ethane dial into the slurry cylinder for me just to try and minimize any of this vibration that's going on due to metal on metal. So this will get me the flow rates done. So let me get that. So check this at 10 and 100. So let me just figure out which tube it is again. Bring it to the near side. Okay. Okay. So you guys can see this okay? Okay. So what I'm going to do is I'll use the large cylinder for the 100 and I'll use the small one for the 10. So I'm going to do this tube here. Okay. So I'll do the 100 first. So let me just get my touch screen in a better position, which is just under here. So I'll change that to 100. Agitate on. I'll set the timer for 1 minute on the screen. So just so you see what I'm doing. So what I'm actually doing here is I'm going to use pump 2.4. It's being agitated currently. I'll set a process timer for 1 minute. I'll start the pump just to get the pump primed and some slurry coming out. And as I drop the slurry tube inside the measurement cylinder, I'll reset the timer. So I'm only collecting for 1 minute. Okay. So maybe I'll show you that part first. Well, I thought I'd just show you me doing it. Actually, it's probably just as easy. Okay. So first of all, got to just turn it on. Make sure I've got the right tube. So I've definitely got the right tube. Okay, so now it's dripping. So just as I insert it into the cylinder, I'll reset the timer. I'll just let that drip for the 1 minute. It's not the most interesting to watch. Thankfully, only 1 minute, not like outgassing. "37 seconds, so we're just over halfway. "45 seconds. "5 seconds to go. Timer finished. We're sitting about, we'll just try and level that off. So I got the bottom of the bubble, 102. So it's 102. So at 100, it's 102, which is okay. And we'll check at the lower end at 10. So just same exercise. Change, reset the timer. Change the flow rate on the screen to 10. Start the timer. Start the process, get it dripping. And just as I insert it, reset the timer. So yeah, so we use 10 a lot on some of the smaller benchtop systems, but with the obviously larger systems, you're going to be using much more volume. So 50 seconds. 55, 56, 57, 58, 59. Okay, and just yeah, dead on 10. So we get dead on 10 millilitres. Right. I'm going to let someone have a look at the vacuum on station 1 just for 1 second. Okay, see if we can figure out the minor leak. Yeah, that's just, yeah, yeah. We think the gauge is just. We'll change the gauge for station 1 for vacuum. Okay, so next check. Let me see. So again, I don't think it's worth me spending time going round every value on every pump. But these are checks that we do as standard across the full machine. So I don't think it's in our best interest to use the time to do that. If that's okay, I can move on. Okay, next check is move the cursors up and down to make sure the shafts move freely up and down. So we've already done that. We've demonstrated that with heads 2 and 4. Ensure that all the correct labels have been fitted to the machine and they're all correctly aligned. So at the moment, they're all done with the exception of the labels on the peri-pump units. Okay, so that I'll leave that as unchecked at the moment, and once they are confirmed, I'll fill them in on the sheet. So I'll just take a note of that on the front page. Also, just give me 1 second. So labels for peri-pump units still to be completed. Okay, next item, I'll leave that unchecked for now. Check all the doors fit correctly and are held in place firmly. Well, we've done that with what we've done so far. Check all the doors operate freely and are visible from any defects. We've done that. Ensure the control panel is blemish free. We've used that. You can see that's fine. So now we're at the Bluetooth section. So this is where we use connect a Bluetooth jig to the machine. So we can walk through that. And let me come down a bit. So someone's going to go and get me a new vacuum gauge for station number 1, since it seems to be that it's not responding. So it could just be that it's a faulty gauge. So we'll change that hopefully before we finish and verify that it's okay. Would be the intention. So let me go to the screen, get a better angle. Okay, so we want to come out, exit, and we want to go into the options screen. Okay, so once we're in the options screen, we go into the pair gauges, so into the Bluetooth section. So I'm going to just empty out everything, so completely get rid of all the Bluetooth. So give me a second. Someone has just lifted my second Bluetooth gauge. Give me a wee second. Sorry, someone had borrowed them, so I've got them back. So currently we have no devices. So there's no Bluetooth connection to anything. So what we've got is I've got 2 displays here. And what we want is to see is the Bluetooth symbol is flashing, so we know it's active. So we've got that on both units. So I'm going to scan. Oh, I need to reset these gauges first. Right, okay, I need to reset these gauges first because when someone's borrowed them, they've connected it to another system, which is just typical. BT reset. BT reset. Okay, right, let's scan again. So what we should see is the available devices that the machine sees after scanning drop into this here, and there's 2 devices, which I'm hoping are these 2 devices, but we'll soon find out. So we'll pair these individually. So one starts the MAC address DA, and the other one's starting E3. Okay. So that first one is done. And then we'll pair the second one. And what that should do is move them from being available devices to actually being paired with the machine, and they should appear here. Okay. So if we check the drop down, we've now got 2 paired devices. The 2 devices I suspect they are now have stopped flashing. So this is solid and this is solid. If you can see, see now. So they're both solid, which means these are paired to something. So these should be the same ones. So if I go jig station 1, definitely I did good connection. It's minus 1367. So I think we can have a guess at which one it is. It's this one. 13, let me get a good angle. 1367. 1366 with a good battery life. Okay, so I'll keep that with station 1 and I'll go to station 3 and I'll pair that with the other one. Oh, sorry. Station 1 is DA and station 3 should allow me to pair E3. So make that one active. Don't think E3. E3 is just, oops, sorry, pressed the wrong button. I wanted to repair E3 because it's not in the drop-down list, unless I need to change the battery. When it's pairing, you can't do anything, just so that you don't interrupt that pairing communication process. Okay, so station 3 will make the other device. There you go, station 3. So station 1 we'll rename the jig. So rather than using this big long MAC address, I'll just call it jig 1, just for some reference. So we'll call that jig 1 or gauge 1. Oops. Jig 1. And we'll execute it to save it. Okay. And now you can see it's called jig 1 rather than the big long MAC address. You could give this the jig actual number, the serial number that's engraved onto the jig, if you do want to control things that way. And then we can call this one, I'll call it jig 3 since it's on station 3. Okay. Okay, now it's called jig 3. Okay. So we can save and exit. So that's us got 2 devices connected Bluetooth wise. So if we go to here, and we've got a door that's open again from earlier. So we'll close that. Okay. So connectivity, that seems okay. So let me go back to the check sheet. So the check sheet is pair a Bluetooth gauge and confirm, that's fine. Check that all settings and connections are saved, and then power down and repower up the machine. So we can check those, so we'll do that now. I'm going to quickly, while we're here, jump forward to some of the safety check. Interlocks are okay, guards are okay, safety labels are okay, and screws are all okay. So with all of those 4 we can do. Yeah, and there's one just as what I can do is we can 0. So what I'm going to do is you can see here 1366. So what I can do is you can see there's the 1367. So I'll try and get these both on the screen at the same time. So there we go, 1365, 1367. So it's getting the live data. Okay, and if I zero, then zero is the gauge, and then the feedback will go back to zero the screen. It's a few seconds delay, usually. There we go, zero. Okay. So just going to power down and we'll reboot the system, make sure the Bluetooth's retained. So switch it off, reboot the system. Okay, that's the system powered down. So I'll power it back up. Is there still? While I reboot the machine, just one of the guys is trying to have a look at the vacuum gauge for station one at the same time. So this is a good time for that to happen in the background. So again, we just wait for the Bluetooth. Okay. Back to the options screen, back to pair gauges. Let me just see what we've got. Just refresh that one. Okay, so that one's fine. Okay, so we're fine. So the connections are all still green, which is good. Yeah. Okay, so Bluetooth reconnection's okay, which is good. And I'll use one of them to trigger. So let me use station 3 at the back. So what we'll do is get a better angle. Here we go. So let me exit options, pair gauges. So I remember which gauge is which. So advice. Why have I just lost it? Sorry, I just pressed the wrong button. Sorry, I've just reset the gauge by accident. Let me just get the connection back. Okay, back in action now. Okay, so use station 3, save and exit. Right, okay. So station 3, so what we'll do for station 3, so we've got -1 micron, and we've got this is in millimeters, of course, so 0.001. So if I zero, it zeros and it goes back to 0. So what we'll do is we'll set this to 100. Why can I not put the number in? Oh, maybe I've not activated it. Maybe my mistake. Let me just double check. Station 3. This is okay. It's active. So I can close. So I can save. Manual. Sorry, I'm pressing the wrong button. That's why. So let's assume we're going to remove 100 microns. I'm sillily pressing this instead of this. So the target is 100. So what we'll do is I'll zero the gauge. Okay. So the number on the gauge is the number. So the number that's on here, you can see is changing the number on here. So if I zero, it zeros and then it zeros. So what I'll do is I'll start a process, mimic a process. And I'll start it. Head 3 down. So what should happen is when I let the probe go, the value will go greater than 100 and the process should automatically stop. So I'm going to let it go now. Oh, gauge is going the wrong direction. Somebody's not set up the direction. I'm going to do that again. Someone's changed the direction of this gauge. Apologies, I'm going to do that one more time. It's better now. Okay, one more time. Start again. So, okay. One more time. So process timer starting. The gauge is the same as the display. Head 3 is coming down. If this was the gauge on, jig number 3, process is running. When this reaches 100 or higher, so slowly let it go. So 50, 60, over 100. So as soon as it got over 100, then the process automatically stopped because I've activated it here. So if you don't activate it, then it will just run on. You need to activate that condition. Okay, if I let it go all the way now, it's going to be 14,000. Okay. This gauge was running in the wrong direction. So what you want to have is when the probe elongates, then it means you're removing material. So we want this to be the positive direction. The gauge was actually set up as a negative downward direction, so you can change the direction. So that was the problem I had there. So I'm happy that if I just let it go, so I'll zero it at the top, so 26 millimeter. Yeah. So what you're normally sitting somewhere in the center when you zero it, and then you'll have something like 15, 16 when you actually then have the travel, because even on the jig, if I show you on the jig, you can see maybe higher. When you see it actually on the jig, you can see there's a little bit exposed. So that's already about maybe 7 or 8 millimeters out the 26. So it means then when the chuck face is coming down, you're then using that kind of 18. There's probably about 3 millimeters for the chuck face and the sample before it's planar with the drive ring itself. So you're probably right about 14, 15 millimeters of travel on the sample. Yeah, so you're probably round about right of the actual relative travel, but the full probe itself is 26. Okay. So that is that. So that's, and then I just need to show you that in recipe mode, and then show again with the USB for saving of the recipe. Just in the background while I was doing the Bluetooth, station 1 vacuum, basically we just changed the gauge. It looks as if the gauge had failed. So if I just show you, if I can try and get the camera in, if you can see that now. So this is vacuum off, vacuum on, vacuum off, vacuum on. So we're getting just over the 20, probably 28 and a half, edging up towards 29 on that one. So that's that one fixed. Now, what we actually found is there was a tube, one of the vacuum's tube it must have been caught, and it had been pinched. So it semi collapsed. Okay. So if I just put a note of that on the front side, so it wasn't actually the gauge, which was what we thought at first. So I'll put vacuum leak on station 1, and I'll put fixed after collapsed tubing replaced. Okay, I'll just put that on the front page just so that we documented that. And so it leaves us with the labels for the peri pumps still to be completed. Okay, so I can mark that vacuum up as 28.5. Okay, so that corrects all the vacuum. Okay, so we're looking at running a recipe. Okay. And then we'll save that recipe, and then we'll reload that recipe from the USB. And then we've already run the load rods up and down, actually all day yesterday and last night to do the last section. I don't want to spend 2 hours showing you the loading rods going up and down. That's something that we do as standard, and we'll continue to do next week. So let me take, and hopefully then we can try and finish just about only a few minutes after schedule, and then I think we'll probably find, I'm not sure if Mark will join or whether I can close. So let me do recipe. So the same situation. So what we want to do is we want to exit. We want to go into recipe mode. Okay, so the screen is identical, just the layout here is a little bit better in recipe mode. We just had to move a few things around just to fit things. Recipe mode's a little bit different. So let me see what we've got. So I can't do anything at the moment because there's no recipe step being created. So I need to create the first step. So I go to the edit button. So the edit button here, this one here. So I need to insert the first step and then decide what I want to do on that step. So we can either insert steps before the step that we're on, but we need to create one, so we need to insert a step after. We can delete individual steps, and then we can actually take steps from other recipes. It's very uncommon, but there might be something a bit more complex. Rather than creating it from scratch, you want to take a step from another recipe. And then what we've got on the left-hand side is the events. So we spoke about the events before. Maybe you want to create, rather than just stopping the process when the target's reached, maybe you actually want to give a warning or a pause, or maybe do something based on a target. So, for example, if you wanted to use 15 microns aluminium oxide for 100 microns removal, and then change to a different slurry cylinder to use 9 microns aluminium oxide for an extra 50 microns removal, then you can use the events system. So if I go to that, the new, so the event, in fact, I need to create the event first. Sorry, the recipe step first. So if we were going to create a recipe from scratch, then the first thing you would probably do is agitate your abrasive. So you probably want to do that for 2, 3, 4 minutes, something like that. So just for speed for today, what we'll do is we'll just do that for 20 seconds. We can give that step a name. So I'll just call it mix or agitate. So I'll just call it mix. So step number 1 is called mix. It's going to be for 20 seconds. And the functionality that's going to happen is we're going to agitate abrasive cylinder 2, R2, which is the upper right-hand side. Okay, 20 seconds, that's all we want to do. Then we want to create the next step. So we'll create the next step. So what would we normally want to do? We would probably then bring some abrasive onto the plate. So we'll activate slurry 2.4, let's call it 50 mLs a minute, and go, so it becomes green. So let's bring some liquid to the plate now that it's agitated. Let's do that, say, for 20 seconds, and we'll call that step as slurry on, even though it's water with some, coolant. So we'll call that slurry. Okay. Then we'll create step 3. So we'll insert step 3. And then we're thinking, well, what do we want to do after that? Well, probably we would want to bring, if it's the jig or the test block, down onto the plate and start the plate rotating. So let's start the plate rotating, maybe slow at 10. Okay. And maybe we bring the carrier on. So which carrier do we want to use, for example? So let me theoretically use carrier 1 and 3 because there's no physical jigs on them, but I'll replicate one of them with this Bluetooth jig here, for example. So that was station 3. So we can see the number that's on this jig, which is 18,045. So we've got the same value here. So let's bring the carrier on. Let's do just make it the same actually. So let's do 10. Okay, and we'll consider this as the jig, and then we'll just make it center track. Okay, so we'll do that for another 20 seconds. So we're talking about jig down. So the process is started. Okay, we'll set a target. So probably after the jig's down, we then want to zero the jig. So what we'll do is create the next step, and what we'll do is we'll zero it so that we're starting from a datum that we know, and we'll remove, say, 100 microns. Okay. I don't want to activate it yet. So what we'll do is we'll create, so that's just the removal starting. So we'll call it removal. And then on the final step, we'll activate it. So we'll just call this the process. Main process. Oh, spelling's terrible. But what we'll do in that step is we'll take up the plate speed slightly. Forgot to put that on. I need to go back a step. Forgot to put the carrier on. I need to go back a step. I should have put the carrier on same time as the plate. So you can scroll through and review your recipe. So let's do that now. So step 1 is mixing for 20 seconds, only agitating. Step 2 is the slurry on, delivering to the plate for 20 seconds. Step 3 is agitation, slurry delivery, and plate on for 20 seconds. Step 4 is agitation, slurry on, plate on, carrier on, and the jig zeroing. Step 5 is then agitate on, slurry on, plate on, carrier on, and we don't need to zero again. And then we want to increment. So we activate at the final step so that we're actually activating so that the process will stop. But what we'll do on the final step to make sure is we'll make this a 5 minutes. So we want this to trigger first before the time expires. So this is going to be the process trigger, not the time. We don't want the time to be too short for 100 microns removal. Obviously, we're just mimicking that at the moment. Okay. So what I'm just going to do is I'll get the probe and I'll just hold it on my fingers. Okay. Just at some arbitrary number. And what I'll do is I'll just insert my USB. And I will, oops, get rid of that. We will, save. So again, I'll go to external memory and I'll give it a new file and I'll call it as talk DL43. Oh, DL43. 43 USB. Okay. So what we'll do, now that we've reviewed it, we can then run the recipe. Oh, one thing I didn't do is I didn't put station 3 down. So I need to go back. So I need to decide when to put station 3 down. I'll put that down on the step just before I bring the carrier rotation on in this case. So I need to resave my recipe, external. I'll overwrite it and then we'll start the recipe. So you can see the recipe name now sits here. This talk DL43 USB.RCP. The time decrement, so the step remaining time is 10 seconds of the 20 we've required. So only agitation. So now we're on step 2, where the slurry, or the water in this case, is being delivered. And I'm just looking at the plate to see if I've got slurry coming on. Okay. Now we're on step 3, where the head is down. That's it coming down. It's now zeroed. And then once it goes on to the next step, I need to just change that. Then I can start letting the gauge go. So we can see the numbers. And the head is then gone up. So the head then, the head's now retracted. And now there's no heads available. So let me just run through that one more time. So I'll just stop that early. So this is slightly different to the smaller benchtop machines, that the trigger actually stops the process. What the trigger in this place will do is it will retract the head, which I need to remember is slightly different. So let me just review the recipe again. That should be on. That's down. That should be down. That should be on. That should be on. That's it. Yeah. So let me resave. External memory. Overwrite. Okay. So let's start again. So first step is agitation on. Step 2 is now slurry delivery. Step 3 is the carrier on and the head coming down. Step 4 is zero of the jig. So now zeroed. Head still down, which is the key. And then step 5 will activate the trigger. And when the trigger is met, then the head will go up. Okay, so I'll start to let this go now. You can see the numbers getting higher. I'll just slowly release it. And when this value gets to the target, so 100 in this case, then this head will rise up. So there we go, automatically. Okay. Okay. So that's all good. Now, the other thing you can do, this isn't in the fat test, but just opportunity while we're here, is this is where you can use the events. So if you press new, then you can decide from here, as you can decide, for example, if I've got something connected to station 1 or station 3 from a Bluetooth point of view, you can use that trigger. So you could do a 2-step lapping process with 2 different abrasives. So you could move from the abrasive here, which may be 15 microns aluminium oxide, to then using maybe this one here, which could be 9 microns aluminium oxide. You could use that trigger. So if I use material 3, you could say when the value is higher and equal to, say, 100, you could then move to another recipe step. So if this was recipe step number 1 or whatever, you could then go to another recipe step. So maybe you moved on to recipe step 5, which then in recipe step 5 might be the other cylinder with the other size of particle size. And then you could make a second event in step 5 to then say when it reaches the extra 50 microns I'm going to take, then stop the process. So you can make multiple triggers based on different things, based on events, as we call them. So that gives you that option, this events section here. If you're just doing straightforward step 1, 2, 3, 4, 5, 6, finish, then you don't need events. Typically, you can use the front screen. But if you wanted to do a dual slurry process using one slurry for a certain amount, then another slurry for a certain amount on the same jig, the same surface, then the events is a good way to do it. Okay. The other thing which we need to cover, I think just from an awareness point of view, I need to reboot and load that recipe. You can also set the charts the same way as we did in the bonder. So we can activate the chart, you can have a look and add the waveform. You could add one of the pumps, for example, or you could chart the removal. So you could actually look at the removal that you've actually got off the jig. So this jig's obviously just sitting at nearly 16,000 at the moment. So if I just fluctuate the gauge, it tracks the live data. And I'll let it go again, and I'll go way back to the top. Okay. So you can look at those plots if that's of interest to you. There are other waveforms in there, not so interesting to chart, but maybe flow rate or maybe something. Plate speed, if you just want to check how stable it is. If I go to plate speed, I'll remove the removal now and just look at plate speed. Then if I started the plate, it's pretty much a flat line. So most of the control items are pretty straight lines. The removals is something you might want to have interest in. Okay. So we'll just come out of that. Oops. So I'll exit. I don't want to resave it because I've already saved it. So what I'll do now is I'll power down the machine, I'll reboot it, and I'll reload the recipe. Okay. So let me just check what else I've got to go through. DL4 done. Check that recipes can be saved to the internal drive. So that's what we're doing just now. And then we can transfer from internal to external. Okay. So apart from reloading the recipe, that would conclude everything for today. So the vacuum issues we had, we've now resolved. And we've only got just an outstanding labels for the peri pumps to finish in terms of the fat tests for the machine. And as I said, there's a few accessories for chuck faces and stuff just need to be, the final machining just needs to take place. So that's the machine off. I'll repower it back up. So any questions at the moment? So I think schedule-wise, where are we? Meant to finish, where are we at? 30 minutes behind, but I guess that was the knock-on from this morning. So,
ну, нет, у меня пока нету, в принципе, это все понятно. Есть, так скажем, технологические какие-то моменты, но это уже не касаемо установки. Вот.
So continue. So recipe mode. So go back in and load this recipe. So I'll go to load. I'll go to my external memory, which is the USB. There's the recipe there, and I'll load it. And we'll have a look, and we'll see it has 5 steps. The first step is 20 seconds doing the agitation on the right-hand side upper. Step 2 is the same, but adding the flow rate coming onto the plate. The third step is the same, but we're adding the plate rotation and the carrier rotation and bringing head 3 down. Stage 4 is all the same, but we're zeroing the jig. Step 5 is all the same. We unzero the zeroing and we activate the trigger to stop the jig and to retract the jig off the plate to stop the removal. Okay, so that's it loaded from the USB. The other thing I can do in the options screen, I can look at the files. So I can look at the E drive. Oops, sorry, pressed too many buttons. Files, E drive, and I should be able to see this talk DL43 USB. So I can do that and I can copy it back to the internal drive. So that's it now on the hard drive. Okay. So I'll just delete it again now, because I know this is the internal drives. I'll delete that just because it's a fictitious recipe. Okay. And then I can exit again. Okay. So I think that's us covered everything. So we've covered all of the items I wanted to cover. I think the only thing out with the labels for the peri pumps for the DL, as I say, the accessories and some of the chuck faces need some final finishing. So we need a few days. So my understanding, I'll just double check with Mark. My understanding is that we expect to ship on Friday next week. So if you guys need any discussion just now, I'll take 1 minute just to go and see if Mark's going to join the call and then confirm the shipping date is Friday next week. So just give me 1 minute and I'll just go and just get Mark if he's coming on the call or whether it is agreed that it's Friday, and then I can take your final questions. Okay. Just give me 1 minute.
Бывает. Поэтому надо рассчитывать, что, наверное, на ДП-4, когда будет предприемка, там весь день, потому что это 2 машины, это не одна даже, и плюс еще CG10 там. То есть это, ну, как бы за один день все успеть. Ну, но все равно это, ну, не в 2 раза дольше, раза в 1,5, вот так.
I'm back. So Mark's unfortunately on another call at the moment, but I quickly did some sign language just to confirm the yeah.
Robin, can I ask you?
Absolutely.
As I understand, we don't have automatical measurement of convex and concave of plate, right?
No, that's correct. So we don't
just
have,
manually.
Just manual. So we don't have, for that size of system, we unfortunately don't have a monitor, an automatic plate flatness monitor for this large size of system. So for the smaller benchtop sizes like PM6, LP70, even those kind of benchtop ones, we have an automatic plate flatness monitor that tells you the shape of the plate in real time. We don't have that sort of technology for these larger systems, unfortunately. So the only way to check that is to use, if I just bring my camera around. So this is why, I've got cables, apologies. That's why with the system, I'll just get my cables. So that's why with the system, what we give you is the Granite Master flat and the dial gauge. So this, if I just take this out, just to make sure you you clearly understand that it's quite tight in this bag. So the dial gauge, basically, we can zero on the master flat. So we know that the probe to the outer ring is coplanar, so here to here. And then you can place it directly on the plate, and then you can see whether it's convex or concave. If it's negative, then it's concave. If it's positive, it's convex.
As I understand, Robin, can I ask you? As I understand, who put it on the plate, we should up some of carrier, right?
Yes. Yeah. So you place it. So what you can do is, if I just kind of relatively show you. In fact, I'll go and get one from the lab, a dial gauge, and I'll show you how you would measure. Just give me 1 second. It's only next door, so I can do this for you just to be sure. So it might not be the same size, but the principle's the same. So this is just a slightly smaller dial gauge than the one you've received. So what I would do is get the dial gauge. I would clean the master flat. I'll just be very gentle on yours. Okay. So I would zero it so that I know this is a good reference. And then lift the probe. I'll take my camera. Hopefully you can see this. And what I would do is sit it on the plate. Hopefully that the probe is not over one of the grooves. I would let it go. And then I can see this plate. Can you see that number? So basically this plate currently is flat, but we've been using this plate recently to lap in some components anyway. So it's not a surprise to me that this one's flat. If the probe is, as I say, positive, it means that the plate shape's convex. So it means if you wanted to get it back to flat, it means that you would have the static percentage at 100% to move the arm more to the center to take off the high spot. If this was negative, so if I just lift, so if it's well negative, it means it's concave. So the high spot is on the edge of the plate. So what you would do is move the arm more towards the 1% so that the test block on station 4 is overhanging the edge of the plate and not overhanging the center recess of the plate. And then you'll get that shape back. You would just stop maybe every 30 minutes or 1 hour and do this manual check.
Robin, for silicon, which is the best? Concave or flat?
Flat is best for silicon, we've found.
Okay.
Yeah. For 3.5 soft materials, you sometimes want slightly convex plate. So the sample is slightly concave because it's the mirror opposite. So that because in polishing for 3.5 semiconductor, you find that it's slightly edge fast polishing. So you try and create a concave sample and lapping so that it's flat after polishing because of the slightly edge fast. So you want a slightly convex lapping plate if you're using the glass. I haven't processed so much 3.5 semiconductor on the cast iron version. That's not our typical process, but we know it can be done.
Okay, thank you.
So yeah, generally flat, perfectly flat for silicon. 3.5 flat to slightly convex.
Now, Robin, in the last time, as I remember, Logitech prepared some paper for the process with the best parameters.
Okay. Yep.
Can you prepare it?
Yeah, we can give you some starting point. Yeah, absolutely. Yeah, no problem. I'll just discuss that with Mark in terms of kind of what kind of format and what kind of thing. He's probably more experienced with that kind of size of wafer with the process release, but certainly we process. So you're looking for silicon using the cast iron, which will probably use the 15 micron aluminium oxide and the 9 micron aluminium oxide. Would that be correct?
As I remember, yes. It's correct.
Right, okay.
And gallium arsenide.
Gallium arsenide using the glass plate and glass test block, I guess. Or is it also using cast iron? Okay,
sure,
using the glass.
Что, Николай? А, у тебя есть какая-то сертификация? Просто я ее не видел. Нет, там прямо именно с процессом, да, то есть они до этого готовили прям бумажку, а там написано было, какое... Ну да, то есть вот столько-то капель, такого-то этого, такой-то конкейв, там, конвекция и так далее, вот примерно такую бумажку есть, да? Возможно, я уже забыл, что она была. Хорошо, ну ничего страшного, если они отправят. У них, я думаю, все...
So silicon on cast iron and gallium arsenide on glass. Yeah? Okay.
Yes.
Yeah, no problem. Oh, yeah, good point. Yep, I'm just writing down silicon on cast iron and gallium arsenide on glass processes, just so I do not forget. Okay, no problem. Yep, we can advise on that near the time, absolutely. Okay, so the tilting of the jig. Okay, no problem. That good. No. I just use, you just use this one. So normally, if you see the difference, so this way with the gauge forward, you see that there's a large opening here. And if I look at this one, I have to rotate it to get the large opening. So if I rotate this 180 degrees with the gauge away, then there's no opening. So what we have is this at the front, so that what we can do is we can lift, and then it's locked in place. So all we're doing is, to put it back down, I pull it forward, and it just rotates on the two pillars here. Okay. So all I'm doing to check the sample or remove the sample from the vacuum obviously is going to be, what happens is the vacuum will come out of these two connections here. We've just plugged this for the demonstration, but the vacuum connections will come down and then vacuum onto the jig itself. So what you would normally do is you would lift up the jig, so just roll it, and then you push it back. And then what you would do is you would then take the vacuum off to collect your sample. And then when you're putting the next sample off after cleaning, you would attach and you would attach, connect the vacuum to the back of the jig and then switch the vacuum on with the toggle switch here. And then the sample should be under vacuum on your jig. So the vacuum on and off is basically here, which is why I wanted to check. So this is the problem with station 1, which is now fixed. So you're only then pulling it forward and then letting it rotate. And then the little locking mechanism takes care of the rest. So on the back side, if you can see, this little air connection here is then where you connect the air onto the jig itself from the machine onto the jig. Okay.
Правильно.
Yeah, so the extra loading weight can come through the drive rod. Okay, so what we can do, I've not shown you that actually, another good, you're getting good at this, Nikolai, you're getting more experience than me. So within the options screen, you've got this. At the moment, it's just the jig, but what you can do is you can actually do additional load. If you apply additional load, so I'll just activate those, and I save and exit. And I go to manual. Then what we'll get is this extra pop-up here. So for the hard materials, maybe your silicon, or maybe if you're going harder like sapphire or something, then you can add an additional load of up to 35 kg on top of what you're going to get naturally out of the collar here. So normally your load is applied via this locking ring here. So you can check that on the jig loading scale. So you can put this under vacuum onto the jig loading scales to check your actual load from the jig only. But then you can add additional load. So if you're getting close to not having enough load that you require based on what's natural from the jig, then you can add an additional load up to 35 kilograms onto each of the jigs. So maybe 10, or you can have 25, or 5, or maximum 35. Okay. Yep. 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 Yeah, and you can measure all of that on the jig loading scales that we provide you as part of the system. So just with the jig under vacuum with the sample on the chuck face, you can then have the sample loading gauges very close to the machine, so that then you're just lifting the jig off the jig loading gauge with a known load that you're going to apply. And if it's not enough, then you can add the extra load through the software here. Yeah. Yeah, I can't remember the total numbers. It's obviously you can add 35 and whatever the natural jig load maximum is. I can't remember what it is. So if I uncoupled the spring, what's the full load from the chuck face? I can't remember the number. I'll have a look at it after the call if you want, and I can give you a number. All right, okay. No problem. I can check it offline after the call before I go home. Yeah. No problem. So I think that's everything that I can remember, to be honest. I think Nikolai's quite rightly pointed out those couple of things. So let me just write another note. So check. So it's going to be jig, max load, and we know we can do up to 35 kilos extra. So what's the baseline that we can add 35 to? And I can't remember if it's 20 or something in that range. 15, 20, I can't remember. But I'll check for you. Okay, so any final questions?
Robin, as I understand, is the best way to use 3 jigs and 1 condition block, right?
Yeah, well, what you would do is the conditioning block on usually station 4, I would do it on personally, is if I'm only using 1 or 2 or 3 stations, I would just leave the loading block in place. I just not use station 4 during the process. So you're either running a conditioning process or you're running a manufacturing process. So the conditioning process is a separate process than running your wafers. You wouldn't run the conditioning process at the same time as your wafers. So you only use the conditioning block to refresh the surface of the plate so that it's not oxidized, for example, if it's a cast iron plate, or you need to shape the plate back to the target that you want. So if it's slightly convex, you want it flat, or it's slightly concave and you want it flat, etc. So only for refreshing the surface and changing the plate shape. That's the conditioning process with the conditioning block, usually station 4. If you wanted to run 4 jigs, then you would remove the loading conditioning block and the extra loading collar that goes on top and replace it with the jig loading collar, which we give you as a 4th spare. And then you can run 4 jigs, no problem. Then if you need to do conditioning again, you would have to change the station back to being a conditioning station.
I understand. It's like we should to use condition block in the morning, in the start of the working day.
Setup procedure, yeah.
Okay.
Yeah. So hopefully if you're running maybe many silicon, then hopefully the plate shape doesn't drift so much, and it's only trying to get rid of the oxidization that's happened overnight. So just a quick, maybe 15, 20 minutes, maybe 30 minutes max. So as you say, a morning sort of setup process just to refresh the surface of the plate with very minimal shaping required after the initial setup. But I think we've lapped the plate so that it's very close to flat. It might be, I think it's flat plus or minus 2 microns or 3 microns or something. So it is very close to flat already for you.
Okay.
Okay. Any final ones? No problem. No problem. This is what needs to be done. So it saves me doing some other things. So sometimes it's a nice break to do this type of thing as well. So, and it's a nice way to finish a Friday when it all comes together. Okay. So as I say, Mark's on another call, unfortunately, but he did assure me that the plan is to ship next Friday. That is the plan. So I guess maybe Nikolai, you'll be in touch with sort of Alistair and maybe Grant for the kind of final arrangements of things. Mark will send an email just to confirm the specific dates, both for this shipment for next week and the fat test on the 23rd and the shipment on the 25th for the DPs. And also he'll give you those serial numbers, those serial plates officially that I've already given you. The only one that's missing is the contact gauge. There is one that needs to be done for the contact gauge, but it's not ready yet. So as soon as it is ready, we'll get that over to you. Okay. Okay, gentlemen. Well, thank you very much. Pleasure's all mine. Pleasure's all mine. So thank you. Have a good weekend. And I will look forward to this one shipping next week. And then we'll get planning for the fat test on the 23rd for the DPs.
Yeah, okay. Thank you.
Thank you. Enjoy, guys. Take care. Stay safe. Thanks. Bye-bye.
Bye.